Hi everyone, welcome back to another Python live stream on Faraday Academy. I'm here again with JT.
Hey everyone.
We were working on Conway's Game of Life last Sunday's stream, and now we're trying to figure out the solution. We worked on it for about 2 hours, and I think we had a pretty good solution, but it didn't work for the test cases. It wasn't complete basically, so we're trying to complete it today. So let me go ahead and share my screen. Here we go. Now you can see both of us in the corner there. All right. Hi nobodies, how are you? First thing, I'm going to take this link to the challenge. So Conway's Game of Life is a popular coding challenge in general, but the specific one that we're working off of is trying to solve the one on Codewars. So I'm going to go ahead and post the link in the chat. I'm doing well, excited to hopefully finish this today. How about you, JT?
Yeah, same.
All right, so we're hoping to get this done in 60 to 90 minutes. We'll see. We did some code from last time, which is in this GitHub gist here. So I'm going to post that in the chat as well. Hi, Samir. How are you? Good to see all you. All right, so we have the code and the link to the challenge. And now, just like we've been doing, JT and I are doing a VS Code live share so that we can work in the same code base and that we can both type and it's not awkward just one of us being able to type in the browser. Hi, Derek. Yeah, so where do you want to start, JT?
So I was talking last time, but maybe instead of grabbing like each of the cell state in this for loop, maybe we should make a function that will just check the boundaries of the array, and then from there determine if we return what's in an array or if it's out of bounds, we can just return a 0, right?
Yeah. Okay. Yeah, that's what we were talking about. I just want to make sure I'm keeping up scrolling with your typing.
Okay, yeah, you should be above the git generation. Okay, yeah. So, let's see. I would just do something like get cell value, and then so we definitely want x and y, right? We should probably also pass in the cells array. That way we can check it.
Is this function that we're making, is that going to check for out of bounds?
Yes. That's why we need the cells multi-dimensional arrays, so we can check as long as x and y are within the length of the cells and then the length of the first row of the cells, then we just return whatever cells x, y is. Otherwise, we return 0. Because if it's not within those bounds, it's out of bounds, and we can just assume that like imaginary cell is off for purposes of generating the next iteration of whatever cell we're looking at.
Yeah. Okay. I think this is a better idea than what we were doing last time.
Yeah, me too.
It's the evolution of what we were doing, maybe.
Okay, yeah. So basically, we just need if. So we're looking at. We'd actually be looking at y first, right? So if y is less than length. Actually, let's do it. We'll start with the min bounds and the max bounds. So if y is greater or equal to 0, that's right. I always switch back to JavaScript because I've been working with 3JS a lot.
It's hard to switch back and forth.
It is. All right, so
that takes you a second to get the syntax.
Yeah, for sure. Here in a couple minutes, I probably won't be making JavaScript errors, but we'll see. So right now I'm just checking if y is between 0, and then the length of cells. And so I'm doing y first here is because the length of cell is going to basically return how many rows you have in the grid, right? So when you look at just the length of cells itself, we're looking at the y values, I believe. Yeah. So then do the same for x. But this time we're looking at cells. We're going to look at the first row of cells because it should be a square grid, I believe. Okay. So
that should catch any. This should catch anything that's actually inside the grid.
Correct.
Okay.
So then we just return cells x, or it's yx, I believe, right? I always do that. I don't know why I get those mixed up because I think like we're looking for. Yeah, okay, we're good. Sorry, I always do that. So then.
But wait, we should we return y is greater than or equal to 0, or do we need to wrap this in a try catch?
No, I don't think so, because the try except or try catch, whatever, yeah, try excepts was only in case we try to access something out of bounds, right?
Okay, so in this function, we're not going to be accessing anything out of bounds of the matrix.
Correct, yeah.
Okay, yeah, because we're not. Okay, cool.
And then so for here, we're going to be iterating. So we're basically doing the same thing. Sorry, go ahead.
We always, because here it says length of cells 0. Oh, because we just need to check the length of one of them. Okay, yeah.
Yeah, because I said square earlier, but it's rectangle.
Rectangle, yeah.
Yeah.
Okay. Cool.
All right. And so for here, what we can do, well, let's see. Yeah, here we should be able to do something that's very similar. So I believe this is ORing itself with another, like, whatever value. So then we can just do get cell value of I and j, and then shift it to the left by 1 for each time.
Okay.
And
so wait, I'm gonna scroll up real quick. So what are we? Okay, so we're returning 0 if it's not returning the value here. Oh, because
right.
This won't be affected, right?
What do you mean? Yeah, like this get cell value is either going to return a 0 or 1. It's only going to return a 1 if wherever the cell is in the array that we're checking is a 1. Otherwise, it returns a 0. But it's just going to basically anything out of bounds is returning a 0. Anything in bounds returns whatever that cell currently is.
Okay.
And then we shift it by 1. So in this case right here, basically what we're doing is we start at this top left one, and we'll do, like, our number would look something like this. So it'd start at OB1, and then it would shift left, and it'd go like, it would, so shifting left would just add a 0 at the end. And we'd see that this is a 0, so this stays a 0, and then it shifts 1. And then so, again, same things happen because this is a 0. And then the next one will be 1, and so on and so forth, because we just keep shifting and then anding onto this last one, right? So then it would just be. So that's the number we're looking for with this input board state.
Okay. We're not adding in extra zeros with the out of bounds though, right? Are we?
We shouldn't, because we're only calling this once for each one of these values, so it should stay as a 9-bit number.
Will it be larger though if we're pushing on? If we're pushing on things, I guess we'll just run it and see what happens.
Okay. I'm just gonna do that, and then. now let's just print out the output board state, and then I'll leave the other stuff in here. Let's just run this real quick.
Okay.
And it breaks. Did it run in your?
So we have a type error.
Oh, I forgot to add the cells.
Oh, okay.
Yeah. Okay.
Cool.
So I don't actually. I think that's interesting. They're all off, which is it's in,
Oh, I didn't realize. So you're scrolling my screen even here.
Oh, am I?
I didn't realize that. Scroll up for a second. Yeah, you're
In the editor?
scrolling. Sweet.
Okay.
Yeah, so I won't touch
Ah,
it if I
man.
see you scrolling.
I'm sorry with anyone with epilepsy because I like jump up and down all over the place.
Yeah, I thought something was wrong with my computer. I was getting frustrated.
All right. Now that we've got that down. So this is interesting that this doesn't it just returns everything as false now. Which it shouldn't. It should be.
Yeah, it should be zeros and ones.
That actually, I wonder if that matters. Because 0 or 1 is could be treated as Boolean too, but it's 100% because of the build state map. This should return instead of false. It should return 0 or 1.
Okay.
And this one already returns 0 or 1 because we're using the bitwise and. So let's try and run again. We should get all zeros, okay, cool. Which isn't actually what we want, but we're getting there.
Yeah.
All right, so what I want to do is actually I already know what cell state is going to end up being, but I just need to check. Man, I can't type today, sorry.
State. Okay.
Yeah. And then let's see what happens. That is not the number that I expected.
So you ran it again. Yeah.
Yeah.
Okay, so you're printing out cell state, which is 426. Oh, I feel like I'm talking over you. Which from this build map, we're looking for all the different possible states that could exist in the cell, and then we're getting a number back out of all 512 different states. But instead of getting different states in each cell, we're getting the same for each cell.
Right, and that's interesting. Plus, now what I'm curious about is going to be what does I just want to see what the binary of that number looks like. I might have ran it twice.
So the binary representation of 426 is this number.
Yeah, and it shouldn't be. This is not what we should be getting from this array.
Yeah.
In fact, specifically, well, that's interesting. Okay. So this is 1, 2, 3. Okay, so there's the right number of iterations, but there's definitely something going on here because it's only returning. If it's only returned the same, something's going on either here or in the get cell values.
Yeah, we haven't got to the expanding universe yet.
Yeah, that's the crazy part.
Yeah, we're still trying to get the right values. All right. Yeah, I guess we're just making print statements to try to figure out why we're getting the wrong number back.
Yep, just like real programmers over here. All right. I just want to get rid of most of these print statements so it's easier to follow along.
Okay, so what are we printing now? We're just printing
The cells X and Y value.
Okay.
Um,
So we're stepping through this step by step to figure out where we're going wrong.
oh wait, I definitely should have kept that.
The other prints.
Just the binary cell state that way, because this is going to be over multiple iterations of the grid, right? So like for each cell in the grid, this is going to print out all of these, but there's no delineation between them, so it's kind of hard to for each of the print values in the for loop inside get cell value. It's kind of hard to tell, like, okay, which cell does this go with? Yeah. So I want to.
Because for every single cell, even though there's only 9 cells in this example, we're checking all of them above and below, and then on the diagonals too. So we're checking 8 cells around the cell for every single cell.
Yep. And then it turns out, and every time I print something out, I realize I need a little bit more information. So let me do that again.
Yeah.
Because these should all. So if we're looking at, we start here. So -1, -1 should be 0, but -1, 0 should also be 0, and then -1, 1 should also be 0. And so for some reason, it's giving us 0, 1, 1. Anything with a -1 should be 0, but it's not always 0, and it's sometimes 0 and sometimes 1, and I'm not sure exactly what's going on, like why that's happening.
Yeah, I would like to see how the debugger works on this, but not this stream, not during the stream, maybe after.
We do yeah, either if we solve this.
Because VS Code live share, I want to see if the debugger doesn't make it crash, because it seems like live share is a bit finicky. What were you saying, JT?
Yeah, I would say we could try it, like, if we figure this out, or maybe like pre-stream next time or whatever.
Yeah, we'll figure it out soon.
Okay, so this is just flat out returning the wrong thing. Let's try something else here. Typically, if you give a negative value for an array, it should give us an out of bounds error, I believe, but it doesn't seem like that's the case right now for some reason, so let me double check. Okay. What I want to do is just print something, so input board state, and then we'll just do, what were the outputs? So -1, 0.
Okay, so you're printing the input board state -1, 0. You're trying to get an error there?
Yeah, I want it to error out because this right here, like if you look in the terminal, the second value -1, 0 for the board seems to be a 1 for some reason, which doesn't make a lot of sense.
Yeah. Okay.
So, and the first one should actually be -1, 0 because we're looking at 0, 0 at that point. So let me run it and see what happens. And we got, scroll all the way down, 1. Why are we getting 1 there? This is, I bet there's something that is, yeah, I feel, dang it, okay.
What?
So -1 gives the last element in the array.
Yeah.
Forgot how Python worked. But we still shouldn't be getting -1 inside the get cell value function because we have a bound around that.
Well, we're getting... Oh, so in import board state, we were passing the wrong thing in there. That's why. But in... Okay. So why don't we step through this from the beginning again?
Okay.
the first thing that we call is
get generation.
yeah, we call get generation. Of course, we pass in the matrix as this cells variable, and then how many generations. Okay, we build the state map, which is just a map of all the different possible conditions, is like a lookup table.
Yeah, it's a lookup table.
Yeah, so we build that, and then we set an empty list to this variable universe so that we can build the new universe. And then we are iterating over the Y column or we're iterating over all of the lists inside of cells, and then it has nested lists because it's in its matrix.
Right.
Or we're iterating all over all the items inside cells, yeah. And then for each row, we're appending a row to this universe, and then we iterate over every single cell inside of that row. We set cell state initially to 0, which means it's off or dead.
Right.
And then we're going through, so this for I in range, so that's -1, 0, and 1, right?
Right.
Okay.
Because the last one is exclusive, not inclusive.
Yeah. Okay, so we have rows and columns for each column inside that particular row, and then we're looping through -1, 0, and 1, and then we're doing that for I and J as well. So that basically brings it, basically all the cells surrounding the particular cell that we've found based off of the index of the row and column from here.
Yeah.
Then we iterate over all of the cells around that row. Now we have 4 nested loops. And then we have, okay, with cell state, this is probably where our problems start here.
Right.
So with cell state, we're calling get cell value, which is what we just added today because we were getting out of bounds errors last time. So we made this method to kind of handle whether it's out of bounds or not, or an actual value.
Right. We were doing some like extra stuff that we didn't need to be. We basically just like abstracted everything we need to do to like check it into a function. That way we didn't have to clutter up like our for loops here.
So if you're using a hash map or do this loop, you could make flat list a key and list of the value.
Wait, what?
I'm trying to read what Derek's writing. It's the next state already generated, that is.
So it's the next state of the entire map isn't generated. It's the next state. So like if you look at a cell, you have to look at all of its 8 surrounding neighbors to determine if that cell lives or dies, right? So the hash map is just determining for any cell configuration given the cell and its 8 neighbors, whether that cell will live or die next generation, if that makes sense.
So that's what the hash map is. It's basically you're passing in a cell and all of the 8 neighbors around that cell, and it gives you the answer whether that lives or dies based off of the sum of all the other ones. And we tested that last time, and that was working fine. Just the hash map itself.
Yeah, it's just the generating the key for the hash map that we're having issues with right now.
Yeah.
But once we can get the cell like generation fixed, then we're on to what I think is the actual problem of the kata, which is the expansion and contraction of the universe. So hopefully we'll get there.
Yeah. And don't forget, if you've joined the stream since the beginning, I posted a link to the challenge at the top of the chat, and also a link to the code that we wrote last time that we're building off of this time, so you can get an idea what we're working on. You should code it yourself. All right. So get cell value is what's returning the wrong thing. So we need to debug this function.
Right.
I think so. By making sure we're passing in the right values, right?
Yeah, when I ran this, I was just passing in I and j. I didn't do x plus I and y plus j. That's still not completely the problem, though, because like the -1, 0 should return 0, and it didn't. So we do have to fix that. But I'm curious, after I've made this adjustments, what the key shouldn't all be the same now. That problem should have been fixed with this.
Yeah. Okay, so you ran it again.
This time we get list index out of range.
But this is good. At least we're not getting the same value for everything. We got 1, 1, 0.
Oh yeah.
Improvement.
Okay, so it seems like it gets the first 2, and it's the third one for some reason that gives us the index out of range, and that happens in the cell states, right? So line 29. Well, yeah, it's this return.
Okay, we're getting the correct values there. So for out of range, then we need to wrap it in a try-catch, right?
Well, I think we don't. This should not be getting an out of range issue or error.
Okay, so let's print out the values and see what we're passing in that's getting out of range, I guess.
Yeah. 0, 1, 2. It's so 3. Okay, yeah, that makes sense that 3 would and -1 wouldn't.
Wait, let me catch up to you. So here are the values we printed.
Did you? Are you in? Okay.
Okay. So yeah, I'm in the terminal right now, and okay, so it printed the same thing again, and then it's showing. It's printing the values after that, and then so when we get the trace back, which value in the cell is that at?
It's this one. If you scroll down to the bottom, I highlighted the 0, but it's the top right basically of the input board.
3, -1.
Yeah, it's right here. So it grabs. It seems like it grabs everything until the bottom. Right. Let me double check. So because that should be x. So 1, -1. Oh, this seems to be going in the wrong order here. So instead we should be doing, I believe, right?
Because it's columns, or no, we'll do rows and then columns.
Yeah, because it seems like it's looking 1, -1 would be x and y, right? So it's looking at this one, and then it goes down. It's looking above this one, and then it goes down to this one, and then it goes to 1. Then it goes back up to like wherever the number would be here, and then down, and then down. And we want it to do across and then down.
But x should be across, right? Unless we did something wrong here.
Oh, I think it's how we're... Because here, if we access it as x and y, the x is going to be the row, and y is going to be... So it should be, well, yeah, it should be y and then x when we're returning it.
Oh yeah, because this is in a list, or nested list. Okay.
Yeah, that's why I keep getting it confused. Like when I put it down here, up here, because depending on what you're doing, you have to access it differently, which is interesting. Okay, let's try this.
Are you
And
running
of
it
course,
again?
yeah,
Okay.
we still got the error, but I want to see. Yeah, okay. Well, that's interesting. We got an error, but I don't. Oh, it's the key error this time,
Yeah.
and it's above 512, which
850.
means we're adding an extra zero. One, two, three, four. Yeah, yeah, we added an extra zero this time.
I think that's because aren't we adding zeros for the out of bounds too?
Um, yeah, I mean, the out of bounds we should be adding a zero. That's what we're doing with when it's out of bounds, right? Because if you look, like right here, we need all 8 of its neighbors, but it only actually has 3 neighbors, so we just assume the rest of its neighbors are hidden and off. Plus, the
Yeah.
x and y values are technically infinite. Um, I am lost as to why. So, okay.
So the get generation function, the get generation function eventually will return the solution. I think that was the default function they gave us in Codewars.
It was, yeah.
So it's not just one generation, it's get the current generation after we've gone through however many generations they tell us. Okay. So in your prints, oh, are you printing out something now? Because I
Yeah, I was printing out. I just print out the same thing, but I added the cells,
okay.
like the
Excel.
actual value. Yeah, that we get from
Excellent.
that coordinate system.
That's good. Okay.
And so, man, some of these don't make sense. We should not be getting. We should only be getting. If it has a negative in it, it should only return 0.
Okay, so let me just step through this real quick. So, yeah, I don't know why the terminal's like stopping halfway. It doesn't let me expand it. Oh well. Let me try zooming
No.
in. There we go. That's better anyway. Okay, so the print statement, where is this binary print statement coming from?
So that comes from the end of the -1 to 2 ranges, the I and J, after it
Okay.
builds the cell state. Yeah.
So that's for every single cell, this prints out the binary. Okay. And
Yeah. So.
then, okay, so first we print out the whole row, and then we're looping through each cell in the row. We're printing out the XY of all the values around that cell, and then the value of the cell itself. And then we're printing out the binary value for the next one, and then the binary value, oh no, the binary value after we print out. So we're getting the error on the third value.
Look, this time it looks like on the second, right?
No, because it successfully prints out the first 2 binaries.
No, it doesn't.
What?
It prints out the second one, but it doesn't. It crashes as it takes the second one to get the cell state map. Right? Like the
Um,
second one is the one that's causing the actual key error.
oh, okay. So where, 1, 2, 3,
I
4,
think the reason we don't for the first one is because for some reason -1, the first two, like -1, and 0, -1, both print out zeros. So when it shifts to the left the first 2 times, nothing happens, and so we end up with an 8-digit number.
Yeah.
When it should be 7 digits technically, right? Because the first 2 shifts doesn't matter. And then this one we get 10, even though we should have gotten 9. So I think what's happening is on this this for loop, we're actually shifting one more time than we need to be shifting. We can kind of take care of that if we just shift to the right once at the end of it. That's a little, I feel like it's a little hacky, but you know.
A little bit, but that's okay.
Right? We should just be able to do this, and that's still not going to give us the correct key, though. And we know that because you can look at the why does my brain stop working randomly? So if you look at the x and y values, you can see like on the first one, 1, -1 should be giving us 0, and not 1. So we're gonna, and then the same as this for the second value in the terminal. If you look, it's -1, 0 gives us a 1, -1, 1 gives us a 1, -1, 2 gives us 0, which is fine. So like there's still some that are giving us
So
incorrect.
are we still looking for the wrong thing in the list? Because
What do you mean?
okay, so this get cell value function we're calling up here, and then if we're passing in, let me open the terminal. Okay, we're getting a key error. Yeah. So we're passing in like -1, 0. But that's not getting the values that we want, right?
Right. Correct.
I mean, we know that, but that wasn't what I meant to say. So we're not, it's not, like we want to look the, above the matrix, you know, to the out of bounds values, but the -1 is still looking inside
Right.
the matrix.
It's
So
for
we're
some
not
reason.
passing in the right, or we're not using the right XY values. Right?
Well, so the problem is if you go to the get cell value function, negative values I don't think should be possible, right?
In here?
Because yeah, because we have the two guards for it, the two if statements.
Well, I'm not talking about the output, but I'm talking about the input when we're looking at cells. That
Oh, what do you, so
so this XY, we should be, because let's say we pass in, I don't know, what is one of these? So we're passing in -1 for the Y, but we're not actually looking at a cell above. You know what I mean?
well, we shouldn't be, the negative should not be in here. Like the negative should never, if there is a negative either one, it should not reach this far. Right?
Oh yeah, because it has to be greater than or equal to Y. Oh, but you're doing or Y is
Um,
greater than the length, or Y is less than the length of cells.
yep. Yep. Yeah.
Yeah,
I
that's
I
why
was
it's easier.
there we go. Yeah, I was originally going to do that, like use this for out of bounds and not inbounds, and then I guess I changed my mind, and I think you should use or in the other situation. Let's see what happens now. This might that's that there's no errors there, so now the question is this correct? So let's see what happens when we uncomment out these print statements. I'm just going to get rid of all the rest of the prints for now, and then we can come back to them. And I just closed it. 1 second.
Oh wait, what did you do?
I closed the Siegel.py, and it went
Oh,
to
okay.
tests. Yeah. So.
Okay.
Oh, I think we've done it.
Oh, sweet. Did we?
Yeah.
Oh,
Uh, although one of these has the number 16 in it. Like if you look at the output array,
yeah.
that's a pictures, it has 16 instead of, so that scares me a little bit, but
Yeah.
I'm pretty sure that's what that's what it's supposed to look like.
Um. So, oh, get cell value YX or XY. So I think we're What are we doing? Where's gets? Oh, I'm in the testing file. Let me go back to
Yeah.
the other file real quick. So get cell value. So we're passing in x, y because we're looping through. So y is the rows, x is the columns, or in this case, each cell inside the row. And then we're passing in the x and the y. So really, I guess it doesn't matter which order we pass them in at. But in this function, we're receiving them as x, y, but we're looking for so inside the cells, we're looking for the list at index y first, and then we're looking for the individual cell inside of the row. So it's kind of backwards here. It looks backwards because of the naming we chose. But
yeah.
Okay. Oh, there's no unit testing, but there are tests to make sure that we pass the challenge. So we're not writing our own tests though. No.
Yeah, I stole all these tests from Codewars website.
Yeah. Okay, so we have something better than what we had.
Yeah, this is okay. So I wonder how we got 16, because next state should only be something that's in the state map, and the state map should only be 0, 0, or 1. Oh, I bet it's. Oh, okay. It's because of how I did this.
Where are you? Okay.
In the build state map. So if I just check. Oh wait, no. This is gonna. I was about to do Python again or JavaScript again. I forget how to do ternary in Python.
You do the actual if-else words.
Oh, that's right. Okay, so basically, it's gonna be like this. So, 1 if that's else 0.
I kind of like that better than JavaScript's question mark colon syntax.
I do too, but like I'm so used to the JavaScript syntax for ternary statements that it always throws me off.
Yeah.
But I think this is definitely a little bit more readable.
Is usually.
Yep. Right. Well, except for on Codewars site, in which case everything's just.
That's people problems. That's not a Python problem. Fitting 100 different operations into one line of code. Okay.
So that worked to make that from 16 to 1 and not get rid of the correct generation.
Okay. So this should work. We should run it again, right? Oops, I just scrolled too far.
Yeah, I did.
Oh, you ran it. Okay. So let me look at the terminal. So it seems like that worked.
Yeah. So I want to try another one. Oh wait, it's not gonna work yet. This is one generation.
Yeah, that's right. We don't have multiple.
Yeah. So maybe what we should do here is take this and abstract it into another function called like next generation or something, and then we can just. Well, I don't know if that's. Because right now we start with an empty. We'd have to start with an empty universe every time we do a generation, right? Which I think might be an issue once we go back to Codewars, because they have like a time limit on the number of, or like they have a time limit for your code to run, which I think we might end up running up against. But for now, we can just actually do probably. Dang it, this, right? So then I'm in the get generations function. If we just do for actually, okay, so the first thing we want to do, now that I think about it, is kind of a guard statement, right? if generation's a 0, we just return what's already there.
Yeah. Okay.
Otherwise, we start actually doing things. So then we do
anything.
Right.
So put it inside another loop. Now we have 5 nested loops.
We are computer scientists, that's for sure.
Well, let's get it
right.
working and then make it perfect.
Right. Okay, so then I think that wasn't. Is this gonna be?
Wait.
I'm in the test. I'm just looking at the input boards to make sure they're all the same. Yeah, all the input's gonna be the same. It's just generation count that's different.
Okay. Derek asks, "Are you putting the full block of 9 into universe?" Yeah. And if so, don't you want the center bit?
I'm confused on what you mean exactly. Like, so we have the full universe, and we're looking basically at it in chunks of 9, right? So we look at the top, we look at the top left of the matrix, and then we look at its 8 neighbors. 5 of them don't exist, but we pretend they do, and we pretend they're 0, and then we go to the next one, and we look at its 8 neighbors, which I think 3 of those don't exist.
So
But we pretend they do and they're off.
I think he's confusing like looking at each individual cell with then returning the whole universe, which actually we are missing a step here because we're not expanding the universe when we
Right.
return it.
I figure let's get the like actual bit like part of it out of the way, and then we can work on the expansion.
Okay.
But because I think what we're going to need to do is every generation we go, we just add a 0 cell to the end of each of the rows, and then we add a whole nother row with that many cells in it, right? Every generation, and then we just check. Before we do any checking, we should expand by 1 row and 1 column. I did that with my hands wrong, but basically one more row and then 1 more column. And then we should check those as well as we're iterating through.
And we could do it the quick and dirty way and, at the end of each generation just manually check if there's a 1 in outer row or column. We just add a row or column of 0s on the outside.
Yeah, that's what I was thinking. What we probably should check if we want to be a little efficient with it is if there is nothing in the after like the generation in the first row and the top row, we could just move everything up to and into the left one, right? Instead of actually expanding it.
Yeah, we could do that.
I'm not sure what, because we have to cut it off as well. Like we don't just have to expand, but we also have to crop it once it's done.
Oh, right, yeah. So we have to.
So
Okay.
Yeah, so it's gonna be we'll probably have just a function that we run at the end of each generation that determines do we need to crop or expand after this, right? Like either move it to the top left or expand out 1 iteration for the next iteration.
Yeah, to crop it though, you'd need 2 rows without any 1s.
Right? You would only need 1 row and 1 column, right?
No, because
or 1 column, I guess.
If I wish I had a grease board here. If I had, I'm gonna copy paste. So, but if I had like 0, 0, 0, 0, but then I had, let me put 1 more in here. So I have 5.
Okay.
So I have 5 here, and I have 5 there. Okay. And then, yeah, I'll add 1 more row. Okay. So I have a 5x5 matrix. So let's say I have a 1 here, right? And then whatever other ones I have.
Yeah.
Okay. 1. Okay. So I have 1 there. So I wouldn't remove this top row because then I would have an alive cell on the outside here. So then I would just have to add back in the top row next time and expand it again. Right? So, but if this were the case and there were 2 rows of all zeros, then I could get rid of this, right? And crop it.
Well, yeah, but like in this case, we can just keep the array how it is right now. But in this case, this is gonna die, and no cell are gonna become alive in this top row. So technically, we could just, for the next iteration, get rid of both of these, right? In this case, I would suggest
Well,
like
this is a bad example, but you need at least 2 rows of zeros to crop, is what I'm saying.
Oh, I see. Okay. I don't. I.
Because otherwise you just have to expand it again.
I think that's something. You're right, but that we worry about until the last generation. But on the last generation, like if there's nothing left, then we get rid of this row. Okay. Or yeah, you see what I'm saying, and then this column as well, okay. Which you can't easily. Okay. Yeah. Because you're right, we could end up just needing to expand either here or here in this example, depending, like, you know, if we had something like that, then we're going to have to expand here.
So we could, what we could do is just never, we could never crop until, it's not very performant, but I mean, we could never crop until the end and then crop. And all we have to do is check to see if we need to expand in the middle of our loops.
Yeah, we could try that. See if that passes the test, and then if not, then we can try to be a little more efficient with it. But that should be fine. All right, okay. So we only ever expand until we need to crop, and then when we need to crop, is there a way we can easily keep track of where the top left of what we need is, or are we just going to have to search for that? That's probably...
We could store it in a variable to just keep track of...
We would have to check every time we turn to cell on if it's the next top left, right?
Well, because we're going from top and left. We're starting in the top left. So we could check for the first thing we find and check the distance. Well, I mean, we could save the top one and the leftmost index.
Oh, yeah, that's fair. So...
yeah. Like the XY of the topmost one and the XY of the leftmost one. That might be what we want to do.
Okay. Yeah, I think that's a good idea. I don't know the best way to do that. So we, do we just keep in well, so part of the problem is the top left one can turn on or off at any time, right? Like wherever if we could have a new top left depending on the state of the entire universe, or we could end up like basically we could end up turning one on. That is the new top left. So are we keeping, like, how are we telling which one is the topmost and which one is the leftmost, right?
I think we should just save the first one we run into that's the leftmost and the first one that's the topmost. And I mean, we can check, so after we check to see if the cell's alive or dead, then we save it into top left. If it's alive, we can save it into topmost or leftmost. And that happens on each generation anyways.
But what I'm saying is, when we're running through this, and it might just be that, like, I'm having a brain fire right now, but as we're running through this, how do we determine when we turn one on if it's the topmost or if it's the leftmost? And that's where, like, keeping track of of like variables that we check against, if that makes sense.
So we're keeping track because we just save which one is the top or leftmost, because we already are checking to see what's alive or what's dead, so we don't have to do that. So we can just say, oh, this is the alive-most one. Not the alive-most one. The topmost the one that's most alive. The topmost one, so we can save and say that, hey, it's in the second row is the first alive one we run into, and the first alive one we run into is also in the second column, which is index 1. The index is, you know what I mean?
Because so the first one we run into is definitely going to be the topmost, right? Like no matter what, that will be the topmost. But the leftmost is a little trickier because if we do something like this, like one, all right, that's the topmost, but it's also the leftmost, right? If we're just looking at the first one we turn on as the topmost, that works. But the leftmost is harder because now it can be any, like say we put the next one is here, and then the next one we turn on is here. Like,
Well, we just
you see what
compare.
I'm saying?
We save the index of the leftmost one, and if anything is less than that index, then we overwrite it.
Oh, okay, that's fair. So the first one we turn on will always be the topmost, I believe, or the first one we run into or turn on.
Yeah.
Either of those two cases will always be the topmost, and then we can also just record it as the leftmost until we find one that has x value that's less than the current x value for the leftmost.
Yeah.
Okay, that makes sense. I don't know why I was like overcomplicating it in my head a little bit.
This is a complicated problem.
Yeah, it's fair.
I wonder, this is crazy because is it really that far of a jump from a level 5 challenge, which I feel like I solve without, any
Well,
issue? Or it doesn't
uh,
take nearly this long. Like it takes maybe an hour to solve.
in my experience, it is a huge jump between 5 and 4. But
Okay.
also, things aren't always are accurately marked for what queue they are. Like, there's been some 5s that I've had that are harder than some 4s, and some
Okay.
4s that are easier than some 6s. Like, it's sometimes the ranking system is kind of hard to use to get an accurate read on how hard the problem's going to be.
Hey, Derek, I always want to use NumPy, and everyone tells me on Codewars that's cheating. So I don't use it in these challenges.
I wonder
Um,
how NumPy would have helped here.
it just helps, like pandas and NumPy and those libraries help with matrix problems, and this is a matrix problem, and it does stuff under the hood. Like it has optimized methods for finding things that you can just call the method that it has,
Oh,
basically.
okay, fair enough. I'll have to look into it and play with it.
Yeah. Um, and also some challenges. So I guess some challenges you can bring in libraries on Codewars, and some of them, like the challenge author, forbids it, like makes it so you can't
Yeah, I feel
enter
like
the
if
challenge.
if they forbid it, okay, it's against the rules. But if they don't forbid it, uh,
Okay.
they did forbid it. Um, so the problem we're gonna have with this for loop that I set up for the generations is that universe is always gonna set to empty, and we're always looking at the cells array. So we're always gonna like each generation is gonna be exactly the same, right? So we need to take universe, and instead of redefining it every time, we actually just need to use universe for the universe generation, and then we can set universe, or actually,
We set it
should we just
equal to
modify
cell.
cells?
Well, we set it equal to cells the first time.
Yeah, okay. I think this is the same thing as just directly modifying cells in
Yeah,
Python,
so
right?
we
Because
would
that's a reference.
slice it if we wanted to do that. Or we could just use cells directly, and because this is just a Codewars challenge.
Yeah, you're right. So we'll just use cells directly, and then instead of universe, although, I feel like if we use cells, well, no, it's the same thing. So if we use cells though, we shouldn't be like appending and.
No. That was just because we had an empty list for universe.
Yeah. Okay. And then we don't actually need to return anything then until after. We can just return cells.
Okay.
And then here we do. This is in the XY, so then let's do it like this actually. So, and here I think this is how we want to do it, and equals next state. And then we get rid of this. And, or we can get rid of that. It might be good to keep it for reference for now though. And we don't need that because we know it's correct. And I guess we just run it and see what happens here, and we'll fix if there's any errors.
Okay. So you just ran it.
This actually is what it should return because generations are set to 0.
Okay, generations is set to 0.
And what? Oh yeah, because we're actually modifying this in input board state, which is why this and this match, even though they shouldn't.
Okay.
So that's interesting. Is when we use the universe thing, it gave us back the next generation properly, but when we modify cells directly, it doesn't.
We must not be replacing the cell correctly.
Let's try X and Y instead. Don't think that's correct, but why not, right?
We should have named them like. Oh, we already have row and column. I don't know.
Yeah, that's the because we had to enumerate here.
Yeah, that's confusing.
Okay. Oh wait, are we actually doing anything with row and cell?
No.
I don't know. I think we thought we had to. Oh, because we were trying to access it out here, which is why. So now that we only need this, we can get rid of the enumeration.
Okay, cool. That'll make things a lot easier to read.
Wow, I just nuked everything. We are gonna. All right, so let's just okay. And then it would be cells like that, right? Is how I would do that. And then we can change Y and X to, in this case, it'd be what, column. And then this one, it would be, or sorry, no.
Yeah, row and then column.
Yeah.
And, okay, because we just, so we're getting the value though for the row, right? No, we're getting the index.
Yeah, this is an index, not the value.
Okay. So we're, oh right, we're adding the index. Okay, cool.
Yep. That should work. Now I want to. But although, well, it should not work. Is actually, let's see if it gives us the exact same thing. What?
Can only concatenate lists, not int. Where are we concatenating? Line 47. Let's see.
cell state is an int. Get cell value should also be an int. Yeah. Let's see what we're getting from. I don't know how it would have changed in the 2 minutes, but.
Okay, it's not even running the first time through.
Yeah, it's not printing. How is this air like? So it's airing out here, right? Or did it air out this time on 47? So it's something in here. So let's print instead of let's just print this.
Yeah, just print the input.
We'll do cells by itself in a second. Okay, that's interesting.
Did you do it again?
Yeah, I did.
Yeah. Okay.
Did it again. Okay, so it's not call.
Oh, wait, because rows is a list. So you're passing in call as a value and row as a list.
Why do I always... Okay, so this should be...
Because, yeah, we need the... Yeah, okay.
Oh, man. This is a pretty common thing for me, I feel like. Yeah, making very obvious mistakes and just not realizing it.
I think just coding all day and then going on a live stream to code more makes it easy to make errors.
So X is not defined. This is on line 52. That is because we got rid of the things. Right? Yeah.
Yeah. Okay.
All right. So we know that this works because this is wrong in the exact same way as it was before. So that's good.
Okay. But it was right when we had universe, and now it's wrong.
Yeah, and that's interesting.
So call and value are correct now, right?
Yeah.
Are we passing them in the right way? So we're passing in column and then row. Well, let's just keep it rows all the way through, right? Just row first everywhere, so we're not confused by whether it's row or column first.
We would have to change the get cell value.
Let me see. Yeah, but only the parameters.
Yeah. I mean, yeah, we could do that. But then in get cell value, like, okay, so if we this is basically the same thing as X is colon, Y is row, so then it would be row col. Okay. Yeah, we could do that. So
then we have to change that. I just don't want to be confused by switching them around anymore. Because
yeah.
I don't think there's a legitimate reason for us to do that. Okay.
Make sure if we pass 0, it doesn't do anything. Okay, good. That's fine at least. So 0 works just like it should, which makes sense since we have the guard statement at the top.
That's pretty straightforward. All right. So why is it now broken again? Let's see.
I'm gonna try swapping these the row and column and the cells equal next state and just see what happens. Oh, it's just row. Wait, what? Okay.
Yeah.
Nope, that doesn't work either because that is not the expected output.
Yeah. Okay.
All right. I feel like this shouldn't be this hard.
No, well, I feel like this is a more complicated solution. Like we could have done this with an easier method rather than, bit shifting and whatnot. But this feels like kind of a cool solution that could be cleaner and
Yeah, I
more
think it'll be
efficient
more
if we,
performant.
yeah, if we optimize it. Like, we're gonna have to, first get it to work and then
Hmm.
figure out how we can make it better. So, okay, now we've added in the generations functionality, and now it's not working. So, where are you typing?
Google.
Oh, okay. I thought you were typing in
Yeah.
here.
No.
Okay. So, if we step through this again, we have cell state, which we default to 0, and then we try to get the cell value here, which also prevents us from getting an out of bounds value. So we call get cell value function.
Hmm.
We check that if y or x is basically if the indexes of x or y are outside of the bounds of the matrix, then we just automatically return 0. Otherwise, we return the value of that cell.
Right.
And then we shift the, oh, we add this on, and then we shift cell state by 1. And then you're shifting it back. Why do you have this cell state? Do you need this still?
Yeah. So remember, we were getting one extra shift
Yeah,
every
but
time. So yeah, I was
okay.
just correcting that.
Okay. So we're shifting each time we're building this we're building the binary value of basically all the zeros and ones that represent each cell state just in one binary value. So we build
Yep.
that here, and then we have to shift back to autocorrect something, and then and that's when once we have the binary value, which maps out the values of all 9 of the cells, including the
Yeah.
one we're looking at and all 8 surrounding it, then we call still then we go to the lookup table, and we get the value. We look up the value for this, which we call next state, which is basically a 0 or 1 if it's alive or dead.
Yep.
And then we update this cells matrix. We update that value in the cells matrix. And I thought by talking through this again, I would figure out the bug, but I didn't. So what do we do now?
Yeah, because it seems like to me at least the solution we have seems reasonable, right?
Yeah.
Um, I'm trying to think that maybe what happened, I was curious if maybe what was happening was specifically that we just weren't expanding, and that could cause it. But that's why I was Googling as I was looking up a current implementation of the Conway's Game of Life to see like what the next iteration would look like. And we are not close to it. So even with the so I just ran it again, and that value doesn't make sense.
Okay. Oh man.
Um,
Okay,
I mean, we
so
might back to just using universe, maybe. Like,
well, the thing about universe is we have to update it on each generation.
yeah. Maybe after each generation we set cells to equal universe, right? So we have this empty array. We create the next generation, and then we set cells equal to that whatever the next generation is at the end of each uh, generation.
But we build the next generation in universe.
Right. And then we just So literally for each time, each iteration through the generations, we just set universe to equal nothing, right? Just to equal this empty array. And then for each row, again, we just append an array, and then at the end here, we will, instead of setting cells, we'll just do universe.append next state again. And then at the end of this for loop, or not the end of the, sorry, right here, because that is...
you'll set cells equal to universe.
Yes.
Inside of the generations loop.
Yep.
Okay.
And another error.
Where is it saying? So line 3.
What?
In HT.
Oh.
Oh, you're not returning anything from... You deleted the return statement.
Yep.
Okay.
Well, it didn't.
Well, we're getting a different...
Line 4 now. Am I doing something?
HTML-wise.
It's saying that the cell is now empty, I think. Or int object. So each cell is now just an integer, not an array.
Each cell should be an integer. You mean the rows?
Well, it's first, or yeah, the row is an integer, I guess. That's interesting.
Okay, so for cell and row int object. So we're getting...
Oh, yeah, we could just look at the output above the picture. And that is not accurate. That is not what we want it to look like.
Oh, yeah. What the heck?
So it's because all right.
Oh, so the values are supposed to be inside of this list, but they're not. They're outside.
So I think what we do is it's universe and then not 0, but it'll be whatever the row is, and then we'll append next state, right?
Yeah.
Okay. Leave us alone about NumPy, Dave. Or is that sent a while ago?
That was a while ago. That's when we talked
I just saw it. Okay. Hey, look! We're back to getting the correct configuration again.
Sweet! Okay, so let's try multiple generations.
Alright, so let's see what happens when we get 4.
Okay, so try 4 generations.
I don't think that's correct.
Well, let's run the test file and see about the tests.
Yeah, let's do that. And oh, look, 3 failures. Yeah.
That's good.
How did we not pass one? Which one did we pass? Okay, so we didn't do 2, 1, or 40 generations. So what is the next?
Which one are you looking at? Are you looking in the test file right now?
Yeah. All right. So we passed 0 generations and none others.
Okay, so we passed our check. Okay. Lovely.
So it was the first array. Let's differ. We're looking. So the first one's import. The second one is supposed to be the expected.
Are you in the?
I'm looking at. Yeah, I'm looking at the
Which
one
line?
generation.
Which line are you at?
18.
18. Okay.
And then I was looking at the tests for this one in the terminal as well. I'm just trying to figure out. So we returned. It looks like did we just return? For some reason, it just returned the input, and not.
Well, what are we returning? Look, in get generation, we should be returning. Oh, these are equivalent though at the end of the loop. That's weird. So it's saying that universe isn't changing.
Right. Let's see if it changes in the 40 generations one. Nope. I don't think so. That's
You're looking
interesting.
at the testing output?
Yeah.
Okay.
I mean, yeah, for some reason it doesn't change anything, which is interesting because it does when we run it, but for some reason.
So an input board state, it works, right? Like if we run Python. Oh, I can't edit the terminal.
That's interesting. I set it up as read write.
Oh, you just allowed me to. I requested access and now it's letting me. Okay,
Okay.
that's fine. Oops. Python. .py. Thing almost needs to be a project board at this point. Yeah.
Yeah, it definitely changes. Let's try 2 generations and see where that gets us.
Yeah, that's
I don't.
definitely changing.
Yeah.
I don't think it's correct. It's not correct, actually.
It's.
Because,
I
like,
think it's
this cell should be on, and this one should be on.
the second one. The second generation is where it kind of gets weird. I think. I can't tell if that's correct or not.
But for the first generation, shouldn't it, if it's surrounded by 3 alive cells, shouldn't it come alive? Right?
What do you mean? Yeah, we're looking at 4 generations in the future, so it's going to be hard to tell,
But
right?
I'm
In that
talking
one,
about when I just did 1. Oh,
well,
was it doing
it
4?
was yeah, it was
Okay.
set to 4 when you ran it.
Oh, sorry.
If you set it to 1, and I just reran it as 1, if you scroll down, it is accurate. Like that is the shape that it should make after 1
Yeah.
generation.
Yeah, because the middle one dies because of overcrowding. The bottom 3 stay alive. Or one of them comes alive. Yeah, that looks right.
And then if we run it for 2 generations, and I just did that now, I can't. I'm looking for I just had the board up here somewhere.
So for 2 generations, let me look back up at because this is what it looked like after 1 generation.
Right.
So yeah, that top middle one died. And then this one came alive, and yeah, that one came alive. That's good. Oh, this one stayed alive, and the left middle one came alive, and then these 2 bottom ones stayed alive, and then that one died because it was only touching 1, right?
Right.
Yeah. Yeah, so this is correct 2 generations in.
Okay.
Except that you haven't expanded it, but everything else is correct.
And then 3 generations in. That should become
Our
alive.
population is dying.
Yeah. I think this is it. I think this is incorrect.
So 3 generations in. I think that's correct. That is correct. Because they're all touching at least.
Shouldn't 3 become alive? Is that the rule? I forget. Is it 3 or 2?
3.
Yeah, so this middle one should become alive, right? No, that's
No,
4.
no, it shouldn't because it was
Yeah.
overcrowded. Yeah.
Yeah, you're right. Okay, so that is correct. But again, we need to expand it for that to be true. But that should be correct. But okay, so then we do that. Oh, yeah, I guess it should be a square at 4, right? Then technically, right? Because all of these have 2 neighbors, so they should stay alive. and then this middle one has 3 neighbors, so we should become alive. And none of the others have enough neighbors to become alive. So if we run this as a 4th generation, then we should get that square.
Sweet. So this is right. Awesome.
I'm kind of excited.
Yeah, me
And
too.
if we keep doing it, nothing will happen. Yeah, that's because a square is a stable block. So without the expansion, it's not going to do anything. Cool. All right. While this awesome that this works, my question is then, why doesn't this work in the tests? Does that mean that I made the test incorrectly?
Maybe, but it's been almost an hour and a half, so I think we should. I mean, now since we got it working, I think we should call it a day and pick this up to figure out how to expand it later, because I think that's going to take another hour.
Yeah, I think you're right. Between now and next time, I'll take a look at the test and make sure that they're working correctly, because it doesn't seem like they are. So I'll figure that out. I did these tests like 10 minutes before the stream Saturday because I was just like rushing. I did not manage my time well last week, so Sunday, there could be an issue. Yeah. Okay. Or did I say Saturday? Yeah, I meant Sunday.
Okay. Yeah, it's okay. We got somewhere today. We got what did we figure out? We got it working. It's basically working, and it's working through generations. So we just need to figure out how to expand it.
I'm honestly like, I kind of like that this one has taken multiple episodes. Like that this is that much harder of a Codewars problem than we have. Like this is definitely making us think a lot more, which is a lot. It's fun, we'll say.
Yeah, maybe it'll make us better. And then we'll try another level 4 after this, and then level 3, and then eventually we'll get to a 10-stream series where we solve a level 1 Codewars challenge.
I'm a little excited and also terrified of that. So.
All right, so for this code here, let's go ahead and post the updated code in this gist, which I posted in the chat already earlier, and I'll post it in the comments right after we finish the stream. So I'll post this gist, and I'll also post another link to the actual coding challenge that we're trying to solve. And then we'll come back in part 3 on Sunday, on Sunday's Python live stream, and try to finish solving this. This has been fun.
Yeah, for sure. I enjoy these. I really like Conway's Game of Life in general. I think it's a really cool thing. You can have all these complex things from very simple rules is really interesting to me. And like theoretically, this should be something that's simple to program, and the fact that it's not is also pretty cool. I think that it's actually a complicated thing. So I'm excited. I'm enjoying it, and I look forward to more.
Yeah, we'll do more and more matrix problems and get better at it. All right, so Sunday we'll be streaming at 4 p.m. I think 4 p.m. EDT, Eastern Daylight Time, and I also have another live stream tomorrow night at 6 p.m. Eastern Daylight Time, which is my regular time for JavaScript coding. So if you want to see me code in Express and Node and Vue.js and help me work on this project that's almost ready to launch, then you can come tomorrow and see that live stream. He said, are there Dan problems or just down to 1 Q?
Yeah, I think there are Dan problems if I'm right. Or there's like you can become a Dan, like Dan 1, Dan 2. So.
What? Really?
Yeah, so after Q, like you go down, so like from Q8 to Q1, and then after Q1, then you become Dan 1, and then Dan 2, if I'm right. Then it starts going back up instead of Q8. It's Dan, or Don. I don't know how to pronounce it specifically, but...
Oh,
yeah.
because that's black belt. You can be a first Dan, second Dan, whatever.
Oh, me personally, I couldn't be, but...
I'm just talking in general. A human.
No, I know.
Okay. Oh, cool. I didn't know it was like that. That's interesting. All right. So yeah, we'll come back with more Code Wars on Sunday. And if you have any suggestions for us, any comments, please leave it in the comments below. Thanks. Please thank JT for coming on and working through this. If you want to join our Discord chat and talk to us about coding and different stuff, the link is in the description. And otherwise, I'll see you on the JavaScript live stream tomorrow and then on Sunday at the Python live stream to finally finish this challenge.
Hopefully.
Yeah. All right.
Yeah, see you guys Sunday.
Yeah, have a good night everyone. Take care.
Good night.